All right. Good afternoon, everybody. Yeah, let's get started. For today, you're going to need to have assignment number 10, the homework assignment, and then the data set that goes along with it downloaded, as well as your group's data set, because you're going to need it for assignment number 10, which is going to be due tonight, but hopefully you'll have about 40-ish minutes to work as a group, which should be plenty of time to get it done. Just some quick information about exam number 3, which is this Monday, this coming Monday. The exam Monday will be open. So it is on Monday, and the exam will be open starting at 1 p.m. and it will close at 3 p.m. Just like with all the previous exams, you're only going to have 1 hour to complete once you actually open the exam. And then it's just like before, it's going to be Respondus lockdown browser. And don't worry about the camera part. I'm just going to turn the camera part off for this exam, just because it seems like it hasn't really been working for the previous exams. With something that's specific with this exam is you will be receiving or you'll have access to a formula sheet. You're not going to need most of the formulas that are on that sheet. I've changed up the class from the previous semesters, and I haven't focused on on how to do stuff by hand all that much. So some of the formulas on there you won't recognize. That's perfectly fine. Don't feel freaked out. You won't really need them. But you will have that. The study guide has been up in the study guide spot on eCampus since Wednesday night. Make sure you take a check, look at that. If there's anything that you feel uncomfortable with, or you have last minute questions, feel free to email me and I'll try my best to help you. So that's the exam number 3, which will be this coming Monday. Any questions about exam number 3 that anyone may have right now? And if you'd rather ask me after class or email me, feel free to do that as well.
So do we need to still use the same Respondus webcam browser, or do we need to use the one without the webcam?
It gives you 2 options?
Well, I just have both downloaded from like a previous class, and you said we weren't using the webcam, so I wondered if you wanted me to like switch to the other
one. I didn't realize there were 2. I would just use one. Just use the same one that you've used for the previous exams and it will be fine.
Okay.
And if for some reason that doesn't work, try the other one. I didn't realize there were 2 different, it gave you 2 different options. Anyways, yeah, just use the one that you used in previous exams. If anyone has any other questions about exam number 3, feel free to email me or see me after class. So today we're going to be focusing on the results section of your paper, as well as how to do one sample t-tests, or excuse me, how to do t-tests. I'm going to go over this results section really fast, just because I just want to introduce it to you. And you've already been introduced to this in assignment number 9. Part of assignment number 9 was writing the first part of the results section. So I just want to briefly go over this because I want to spend more time on t-tests. So why do we write a results section? You collected your data, you did all this stuff. I'm not going to pull up that slide again where we talk about the steps that we've been doing, but you collected your data and you analyzed it. Now we need to actually present the findings of our study. So that's the purpose of the results section, to present the findings of your study. There's a couple things that make up a results section. You have the descriptive statistics, which assignment number 9 was all about. And this is kind of, what did you find about your specific variables? What were the means? What were the standard deviations? Was there any skew? And then you also have a section for inferential statistics. And remember, we talked about inferential statistics last class, but this is about, did we find patterns in our sample data that we can apply to the population? So this is going to be things like maybe a one samples t-test or some correlations. So right here we have, were the results of the correlation statistically significant? And last class we talked about what statistically significant was. Next week we're going to apply them specifically to correlations. But yeah, so this is the purpose of the results section. They're in all caps here. It says do not interpret, and this is really key. The results section is not for you to say, hey, this is what we found and here's why we think we found it. We think we found it because of this theory or for these reasons. No. All you do is you just say, here's exactly what we found. Here's what the math says. Interpretation is done in the section after that, in the discussion section. So it's just the facts. So this step number 1, where you report the descriptive statistics, you've actually already done this if you've done assignment number 9 already. And just as a reminder, assignment number 9 is due by midnight tonight. But what do you report typically? Well, this is just mean and standard deviations of some of your variables, but it also depends, depending on what variables you have. Sometimes you want to report, if maybe your main variable is ethnicity, and you would report, how many different people were in each different ethnicity. If that was what your research question is about, you should all be reporting ethnicity rates in your participants section. But if your research question revolved around something like that, you'd go past mean and standard deviation into some other stats. But for us, it would just be mean and standard deviation and potentially skewness. So which variables do you report on? Well, since we're doing a correlational study, it's just all your measured variables. If we were doing an experimental study, which you will be doing in 204 next semester or whenever you take it, it's the dependent variable for each experimental group. Don't read too much into that. You'll talk more about it in 204. So you don't just list the numbers. You don't just say, hey, the mean is this and the standard deviation is that. Instead, you need to put it in a meaningful sentence. And assignment number 9 walks you through that of what a meaningful sentence looks like. We give you an example. I'm going to say it now, and I'm going to say it several other times in the coming weeks. For the results section, we give you the paragraphs you need to use. Copy and paste the paragraphs, the example paragraphs we give you, or they're not even paragraphs, they're just 2 or 3 sentences, and plug in your own information. Don't try to change the sentences we give you, besides from the numerical information you get from your tests. Keep the same sentence structure in words. But anyways, you need to report the statistics as part of meaningful sentences, something we'll do, you did in assignment number 9, and you'll also do in assignment number 10, so you can see what those sentences look like. And then when necessary, you need to put these numbers in context. Indicate what a high number versus a low number means on your self-esteem scale. What does a high score represent? What does a low score represent? So put these numbers in context. So that's the first part of the results section. And I'm going to pull up an example from a student paper that does this perfectly. So here's an example, and you saw this exact paragraph on assignment number 9. So I'm not going to go too much into it, but you can see we have the mean and standard deviation for one of the variables, the sleep quality. And we give, it's out of 36 points. So it kind of puts it into perspective, that mean of 14.25 out of a possible 36 points. And then we talk about on this scale, what do higher numbers represent? Then we have the next variable. It looks like we were doing some exam, right? The average exam score was this, standard deviation, and this data was actually skewed. So if your data is skewed, this is the type of information that then you would need to include. We'll just talk about the skewness a little bit. All right, so this is assignment number 9. No one's asked me any questions so far about assignment number 9. I haven't received any emails, so I'm assuming this is making sense to people. Step number 2, and this is something that we'll get into more next week, and so I'm just going to go really briefly over this, but this is where you report the results of your hypothesis test. So for us, it's a correlation. So you need to state what test you're using, report your findings in meaningful sentences, and then back up your findings with inferential statistics. So here's an example, a quick example of a Pearson correlation write-up. This is something you'll have to do. Don't read into it too much. I'll talk a lot more about this next week, but it is on this slide in case you want to look at it. Here's what the write-up will look like. Some general guidelines when writing a results section: write everything in past tense. The second bullet point is just make sure you incorporate your numbers in meaningful sentences. That's all that means, something we've just talked about. And then include tables or figures or graphs as appropriate. But we'll talk more about that with the correlation. So I want to show you an example of a student paper of a results section, just to show you what you have already. This is a student from last year. And here's this results section. So I want you to pay attention to this results section. This part in yellow is assignment number 9. So after you finish assignment number 9, you can just, after I provide feedback for it, you can just copy and paste that directly into your results section. assignment number 10, you're actually going to get this red sentence. This is going to be, we're going to be conducting a one samples t-test on either the perceived stress or the self-esteem score, whichever your group used, stress or self-esteem. And so you'll have an output of just one sentence that you can paste into your results paragraph. And I give you the sentences on assignment number 10, but we'll get there in a little bit. And then finally, this will come next week. You have one or two sentences regarding the correlation. So this is all the results section is, and this is all it will be for your paper. Not too bad. And after today, you'll have, 9/10 of it done already. So this is, one of the reasons why you should be keeping up with the assignments, because we walk along with the paper with it. Anyways, here's the results section. I went over it really fast. We'll go over it again in more detail when we talk about correlations, but I just wanted to show you assignment number 9 is this information. Assignment number 10 is this, and all we have left is that. Any quick questions about the results section before we jump into t-tests? Let me open up chat. Okay, not seeing anything. All right, so let's jump into t-tests. I've done all of this out of scratch. I'm kind of going away of what we typically learn in Psych 203, went off on my own path. So this slide right here is what I think you need to know in regards to just what you should know about t-tests, but also more specifically, what you will need to know for an exam. Because I think that's what most of you all care about, right? What you actually, what do you really need to know? So today we're going to be talking about all this, but I just want to walk through it really briefly. We're going to be talking about the different types of t-tests. There's actually 3 that we're going to be talking about, and we'll get into that. Something else that we're going to go through, and this is probably one of the most important bullet points on this, is what question each t-test can answer. So all t-tests kind of do the same thing, and we'll get into what they actually do, but each specific t-test answers a really specific question. And that depends on your research question, whatever you're hypothesizing, whatever your design is. So for example, one of the things that you're going to learn out of this, and what I hope you'll know, is you'll know when to use a one sample versus an independent sample versus a dependent sample t-test. For each of these tests, you'll need to know what type of data is needed to actually run that test. For one of these tests, you need a certain type of data. For another test, you'll need a different type of data, and we'll go through that. Then I'm going to show you how to run a one samples t-test and an independent samples t-test in SPSS. For the purposes of an exam, you'll only need to know how to run a one samples t-test. Well, actually, you'll need to know how to run a one samples and an independent samples t-test. But for your paper and for this exam number 3, I'm not actually going to ask you to run anything. That will be for the final exam. But for the purposes of your paper, you'll need to know how to run a one samples t-test in SPSS. And then you'll need to know how to interpret and write up an independent samples and a one samples t-test, but we'll get into that today. So these are the things that I want you to know, and we'll walk through all of this for each specific test. So before we jump in, can someone give me what they think a t-test does? If you had to summarize, what a t-test does in 1 or 2 sentences, can someone take a stab at it, unmute themselves, and just tell me what they think a t-test does, or what types of questions it can answer?
Do t-tests have to do with like statistics, right?
Yep. Sure. T-tests are about statistics. So this is actually one of the first, besides from the descriptive stats you talked about, this may be one of the first statistical psychological tests many people in this class are ever going to do. So good. It's about statistics. What types of questions can they answer? They answer a very specific question.
Doesn't it tell you like the differences between the groups?
Perfect. That's perfect. A t-test, the practical definition for a t-test is a statistical test used to determine if there is a significant difference between the means of 2 groups on one variable. So let me repeat that again. A statistical test used to determine if there is a significant difference between the means of two groups on some variable. So like Hannah said, we're just seeing, do two groups differ? Now, I have two groups in asterisks because there is a slight catch with that idea of two groups that we're going to get into when we talk about each individual type of t-test. But for the practical definition, just examining if two groups differ on some variable. So here's some example questions that we can answer with different types of t-tests. In our sample, do boys and girls differ in self-esteem? Right? It's a simple question. We just want to know, do boys and girls differ in their levels of self-esteem? Mathematically, what a t-test does is it takes the means for boys, it takes the means for girls, and it says, hey, are they different? Another type of question that we can answer is, what if I want to know, hey, does the average exam 2 grade for this class differ from the exam 2 grade for the average Psych 203 student in the past? So I know what the Psych 203 exam 2 average grade is for previous classes. Let's say it was a 75%. And then I could look at your exam 2 scores for this class and say, hey, do these groups differ? Are the exam scores different? Another type of t-test, or another question that we can answer with a different type of t-test, and this is really the reason for that asterisk on that two groups here, is I could also answer the question, is my mile time different after training for 2 months? So you can see the slight little caveat here. I'm actually just comparing my pre-training mile time to my post-training mile time. It's not technically two groups, but it is two different like time points, I guess, if you want to word it like that. Right, so I run a mile, and then I go through 2 months of training, and then I run another mile, and I have my entire sample do that, 100 participants or whatever, and I can see, hey, does the first mile time differ from the second mile time? So these are the type of questions that we can start to answer with a t-test. But there are different types of t-tests. So here they are, and we're going to go through each one of these. The first one we're going to go through is a one samples t-test. Then we're going to jump into an independent samples t-test. And then finally, we're going to briefly talk about a dependent samples t-test. Some people may have heard it as paired samples t-test. So the three different types of t-tests we're going to be talking about today and what you'll need to know for the exam. So let's jump into the one samples t-test. And this is actually the t-test that you're going to be doing in assignment number 10 and for your research paper. But a one samples t-test examines whether the mean of a group, let's just say your entire sample, if it's different from some known value. So we already know this value, and we're just going to see, hey, is our sample different? So here's an example of this. This is the example that I talked about earlier. Does this class, exam number 2, differ from previous classes? So I already know, it is all in the past. I already know what the average Psych 203 exam 2 grade is. Then I can see, hey, does this class differ from that? I could also have all of you take an IQ test. And so I would have, 25 people, 25 different IQs. I could find the mean of that. So, just find the average IQ for this class. And I could say, hey, is this class IQ different than the national average? And I know the national average is 100. Another example, does our sample differ in self-esteem from some other sample? And this is actually the question that you're going to answer on assignment number 10. We're going to give you the self-esteem average for some other sample and some other study that was done in the past. And you're just going to you're going to be able to answer, does our sample, the participants that you collected, differ from this other sample that was collected previously? So for the purposes of this class, you'll always be given this other known value, right? If it's a homework assignment, we give you the value. We say, hey, the average is this. We actually tell you what the average for this other sample is. So that's actually one of the easiest ways a little cheat trick, I guess, that, for a homework assignment or for an exam, we'll always give you this other known value. So if we ever give you a known value and then ask you, hey, what type of t-test it is, it's always a one samples. So this key distinguishing feature of a one samples t-test, it's comparing the means of two groups on one variable, but you already know the mean of one of the groups. And here are just some more examples of some questions that you could answer, right? If I wanted to know, does this class IQ differ from the national average? I could answer that with the one samples t-test. I could have all of you run as fast as possible, find out your mile per hour, and then I could see, hey, does this class differ from the average speed of an Olympic runner, which is 26 miles per hour? I could add up or average all the male heights in this class and find out, does the average height of a male in this class differ from the average height of the male in the US, which is 5'9". And like in assignment number 10, what you'll have to do in assignment number 10, we can see, does your sample, the participants that you collected, self-esteem scores differ from some other previous sample? And we would give you, the other sample's average self-esteem score. So this is the type of data that you need to run a one samples t-test. In your sample, you need to have one continuous variable, right? Which just means some variable that is not categorical. So some variable that varies numerically, right? So in our data sets for your groups, you have things like self-esteem and perceived stress and body image and social media addiction and exercise. These are all examples of continuous variables. What some other ones could be depressive symptoms. I'll have an example later about depressive symptoms. Time spent studying. So what if I wanted to know, does this class time spent studying for the final differ from previous classes? Age can be another one. So you need one variable in your sample, right? Let's just say self-esteem. Well, then you also need to know the mean value from another sample, right? I need to give you the self-esteem score from some other previous sample. I need to give you a stress score or a depressive symptoms score or the average time spent studying or the average age. So two things you need. In your sample, you need some variable that is a continuous variable, and then you need to know that value for some other sample. All right, so the next couple slides, I'm going to walk through how to do a one samples t-test on SPSS. It's incredibly simple. And then I'm also going to walk through how to interpret the output and do a write-up of it. I'm going to walk through it in pictures first, and then I'm actually going to pull up SPSS and walk through it, do the point and click with you or show you, because this is what you'll be having to do for assignment number 10. So let's say our research question is, does our sample's mean age differ from some other sample's age? So in a prior study, so if this was a homework assignment or a test, I would say, hey, in a prior study, we determined that the sample's mean age was 25 for that sample, right? So I give you this value, and you'll see why you need this value. So this is how you do it in SPSS. You go to Analyze, Compare Means, One Sample T-Test. And once again, I'll actually walk through this and show you. But Analyze, Compare Means, One Sample T-Test. Whenever you click that, this box will pop up. So all you need to do is bring over your variable to the test variable box. All your variables in your data set will be on this left-hand side. So going back to our research question, I want to know about differences in age. I bring over my age variable to this test variable box just by clicking this button. Then in the test value box down here, it's a little small box, you just put the known mean value. So we'll always tell you what this known mean value is, and it's 25 years old. So I put 25 in there, and then all I got to do is click OK. So bring over the variable I want to know about, put in the known value, and then click OK. That's all you got to do. So interpreting the output. So this is the output that comes up after you run a one samples t-test. Up top, it's going to output two boxes, right? And this is exactly what it will look like. So two different boxes. In the first box, it just tells you, hey, here's your variable. What is your age? right? The question that we asked. Here is the mean for your sample. Turns out the mean for this group was 29.2. Here's the n, so here's how many participants answered that question. And then here's the standard deviation, right? So if you're going to report, if you wanted to know the mean, or if you had to report the mean and standard deviation, right here it is. It's the mean and standard deviation for age. All right. The next box is the actual inferential statistics part. It's the stuff we really care about. I mean, we also care about the mean and standard deviation, but here's the actual t-test. So you can see if you did it right, that value you put in the previous slide, 25 years old, should show up right here. So it's a good way to double check to make sure you actually typed it in correct. And then we have some interesting output here. So before I go into it, can someone tell me, do they think this is significant or not? Actually, do it in the doing a direct message. I'm not going to tell you where to find that information. Talked about it before and used some context clues. Is this significant? Do the direct message in chat and let me know. Yes or no? Is this significant? All right, I'm seeing a majority yes, but there are some no's. So yes, it is significant. And how do we know that? Because P, or this significance box, is less than 0.05. P is less than 0.05, so we know it's significant. So since the p-value is less than 0.05, we can determine that there is a statistically significant difference between the groups. So we see this little box that says significant or significance. It's abbreviated for significance. P less than 0.05 means it's significant. So it also gives us some other information that we need whenever we're writing up our t-test write-up. We have the actual t-value, which we'll be getting into near the end of the semester about what this actually is. The degrees of freedom, once again, we'll get into that later. Just know that that is what they are. So, go to the next slide. So this is the write-up for one samples t-test. I have it here. I have it in assignment number 10 as well. So, you know, for the purposes of your paper and this homework assignment, anytime you do a one samples t-test write-up, or you have to do a write-up, you can just use this exact same sentence structure. So according to a one samples t-test, there was a statistically significant difference between our sample's age, and this is where we put in the means then. So we put in our mean sample age, which we can find up here, and the prior study's age, the test value that we give you, the mean was 25. Then we got to do comma, t, parentheses, degrees of freedom, which is 243, equals the t value, 4.48, and I got that from here, comma, p equals, and then we put the p value. Right? This is how you report it. Easiest way, this is what I did as a student many years ago, is I would have this write-up, and I would also have, like, on a Word document, I would have this write-up, and I would have this output, and so that way I could exactly see, okay, here's where the numbers come from, right? All you got to do is put this number, this DF, degrees of freedom number, right here in parentheses, equals this value, comma, P equals this. And then we need a sentence, if it is significant, where we talk about, okay, so we need to interpret these findings, or not interpret, but we need to say, okay, what were the actual findings then in plain English, right? Because this numbers, okay, they're numbers, whatever. What does it mean in plain English? Well, can someone, it is right here, but if we know that there is a significant difference, even if I didn't tell you right here, okay, what does a significant difference mean? It means our sample age is different from this other sample age. So then let's look at it. Our sample age was 29.2. The other sample age was 25. So that means our sample was older. It was statistically, there was a statistical significance in the difference. Our sample was significantly older. And then I just say, hey, specifically, our sample was older by about 4.2 years. And there's two ways to find this out. You could just subtract, right? I could just take 29.2 minus 25, and that gives us 4.2. Or you can use this mean difference. It actually calculates it for you. So it's just 4.2. It's off by some rounding. So 4.2 years. Does anyone have any questions where I got this information from out of this output? One of the things on the exam, one of the things for the final exam, not exam number 3, but the final exam, is you're going to have to conduct a one samples t-test and give me the output. So it will be open note. I'm going to say right now, the exam number 3, this portion will be open note. So I highly recommend that you have, some version of this slide where you have this example write-up and the output. So that way you can match it and then you can recreate it with your own data. All right, so that's the one samples t-test. Let me show you in SPSS what it looks like. So this is group number 1's data, but I will be conducting a one samples t-test, but the numbers will be off just because, actually, let me explain why. So all groups need to do this with their data. For some groups, if we can see this age, I made a mistake and I didn't delete people who were under the 18. So for all of your group's data, for all the groups, make sure that all your participants are over the age of 18 and delete the ones who are not. And let me show you how to do that, or the easiest way to do that. So, open up your data set, at some point, right click on this age variable and sort by ascending. So right click, sort ascending on age. And what that will do is just reorganize all the data and the participants in ascending order of age. And so we can see there's one participant is 12, a couple 13s, 14s, 16s, whatever. So all you need to do then, once you sort ascending by age, is delete everyone by highlighting everyone who said they were from under the age of 18, essentially. Highlight them all by clicking and dragging over here. Right click and then clear. So just make sure that you clear everyone or you delete everyone who said they were under the age of 18. Keep the people who didn't supply an age, just delete everyone who said they were under the age of 18. It's by deleting all their data. All right, anyways, make sure you do that. Make sure all groups do that. But to run a one samples t-test, analyze, compare means, one sample t-test. It's kind of hard to mess it up. It tells you exactly one sample t-test. It's going to here's this box. So I'm interested in age. I bring it over. This won't be here. My test value, which we will always give you, is 25. Click OK. And then it's going to bring an output, which looks like this, right? And now we've already seen this, but here's what the output looks like. I didn't want to, this won't be here. Exactly what I showed in that PowerPoint slide. Here's the output. And so, all you need to do, P is less than 0.05. I know there is a statistically significant difference. The difference is our sample is older than the other sample, and I could report those statistics with that write-up. All right, one samples t-test, incredibly simple, couple clicks of a button to get this output, and now you know how to interpret that output. This is what you'll be doing on assignment number 10. But before we get there, let's jump into talking about the other different types of t-tests. So that was a one samples t-test. Does anyone have any questions about a one samples t-test? All right, not seeing any. Let's move on to independent samples t-test. So an independent samples t-test is kind of what the traditional definition of a t-test is. It examines whether the mean of a variable for one group in your sample differs from another group in your sample. So do males and females differ on self-esteem scores? Is there a difference between freshmen and seniors on how much they exercise? You have two groups in your sample looking at, and we're comparing, are they different? So let's talk about the data needed to run an independent samples t-test. It's different from a one samples t-test. In an independent samples t-test, you need one continuous variable in your sample, right? Age, self-esteem, some variable that is numeric. But you also need one categorical variable with two groups. So an example of this is gender, where we have gender broken down by male and female. Now, I know in our own sample, we have gender broken down by like male, female, non-binary, and like prefer not to say. For the purposes of, you can just say male and female, like, and just only use those participants. So we are only comparing males and females. Let's say we had a data set of smokers and non-smokers. Well, we could compare them on some other variable, right? Do smokers differ from non-smokers? What if we wanted to see, do African Americans differ from Caucasians? We can look at that as well on some variable, right? On self-esteem, on depression, on grades, whatever. So you need one continuous variable in your sample, which will be your dependent variable. And your independent variable is one categorical variable with two, it's important, only two groups. So let's say our research question is, do boys and girls in our sample differ in how many depressive symptoms they reported? A common question you might be interested in. So this is how you run it. Once again, you don't have to do this for the exam or for the final exam, and you don't have to do it for your paper if you don't want to, but here it is. You will have to do it in 204, so I do want to talk about it now. But analyze, compare means independent samples t-test this time. This box will pop up. You bring over your dependent variable, which is your continuous variable, that variable that you're interested in, self-esteem, whatever, and you put that in the test variable box, just like before. Then in the, this is not the right one. Ignore this. This is how to do a one samples. Ignore this slide. You don't need to know how to do an independent samples t-test, but before I upload this, this PowerPoint to eCampus, I will fix this slide to show how to do an independent samples t-test. But doesn't matter, you don't need to know how to do it, but what you do need to know is how to interpret the output. All right, so this is the output that pops up when you run an independent samples t-test. So you're going to get two boxes again, but this time, this first box displays the means of the dependent variable for each of your two groups, right? So we're looking at gender and depressive symptoms. It gives us the average amount of depressive symptoms for males and the average amount of depressive symptoms for females. And it also tells us how many males and females we have in this N column, but we specifically care about this mean standard deviation. Now, using this first line, and I'll get into using this first line, apply that same logic we did to the one samples t-test. I have the important numbers circled. Is this significant? Using the direct chat, tell me, is this significant? All right, good. Everyone's saying, for most part, everyone is saying yes. And why is it significant? Because P is less than 0.05. All right, someone tell me, unmute themselves. We know that it's significant. Tell me what it means. What do you think it means? That there is a statistically significant result here. Remember, we're looking at gender and depressive symptoms.
It means that there's a statistically significant difference between the two groups.
Perfect. And what is the difference? What does it look like?
Like the number?
Tell me, who has more? Who reported more depressive symptoms, male or female?
Female?
Perfect. So we know there is a statistically significant difference, right, between our two groups. Well, what's the difference? Females reported 16.4 depressive symptoms. Males reported 12.21, excuse me. Females reported more depressive symptoms than males. So since the p-value is less than 0.05, we can determine there is a statistically significant difference between the two groups. And then this is the write-up for an independent samples t-test. Going back to this slide, actually, so I'm not going to get into it today at all, but if I ever, for the purpose of the final exam, if I ever have you interpret this output, the t-test does technically give you two different like rows here, and they mean slightly different things. For the purpose of this class, always just interpret the first row that I have highlighted here. I'm not going to get into what this is. If people are interested in this Levine's test for equality of variances, stay after class and I can explain it in 2 minutes. Just always use this for the purpose of this class, always use this first row. Don't worry about this second row at all. All right. So this is the write-up. I'm going to go through this really fast just because I want to give you as much time as possible to work in groups on assignment number 10. But just like the one samples t-test, the write-up would be, according to an independent samples t-test, there was a statistically significant difference between males and females on average depressive symptoms. And then, just like in the one samples, I do T, in parentheses, the degrees of freedom equals the t-test value, -4.198, comma, P equals the p-value. Everything is, reporting it is the exact same as the one samples. And then I say specifically, because it was significant, I got to explain a little bit more. Specifically, females, mean and standard deviation of the depressive symptoms, which can be found up here, reported more depressive symptoms than males. And then I report their mean and standard deviation. That's all there is to it. Do people feel confident that if they have this as a like a cheat sheet, right? Because this will be open note for the final exam on this part. Would you be able to tell me if I just gave you this output, would you be able to tell me if it was significant or not? And if it is significant, could you tell me, could you basically tell me, write this up? That is something you'll have to do for the final exam. But once again, it will be open note. However, it will be a timed test. So, if you don't know it, you might run out of time. So, do make sure that you at least have a general idea of how to do this write-up or what these outputs mean. All right, I want to do the dependent samples t-test really fast. I'm not going to show you the output, but there is some important information to know. So the dependent samples t-test answers the question, is there a difference in one variable measured twice by the same individual? So some type of questions that could answer, is there a difference between self-esteem scores pre and post therapy? So we have a sample, right, of participants. We take their self-esteem score prior to therapy. They go to therapy for 2 months. We take their self-esteem after therapy. Are the scores different? So think of this as any pre-post design, right? Where we measure something pre, we do something in the middle, and then we measure it again. That could be answered by a dependent samples t-test. So the data needed to run a dependent samples t-test is just one continuous variable in your sample that each participant takes 2 times, right? One variable, self-esteem, depression, whatever it is, just measured twice. And then you could see, do they differ? Relatively simple, but we're not going to get into how to do it or the output. It's not needed. You can do that in 204. So at their core, this is an important slide, at their core, a one samples t-test examines if your sample's mean for a variable is different from another known mean. An independent samples t-test, on the other hand, examines if 2 groups in your sample are different on some variable. And then a dependent samples t-test examines if the mean of a variable measured at time 1 is different from time 2. So at their core, I like this slide because it just says at their core, here is what each test does. If you can understand, if you have a deep understanding of this slide, you'll be able to accurately answer any question I throw at you. And so let me throw some questions at you. So in the direct chat, and these are the type of questions you may not have ever been experienced to before. So if I gave you 2 variables, what type of test could you run? So what test can you run with these 2 variables? I give you gender, which is broken up by male and female, And the other variable is IQ, which is a continuous variable and it ranges from 60 to 150. What type of test can you run here? A one sample t-test, an independent samples t-test, a dependent samples t-test, or no, you can't run any t-test with these two variables. I'll give you about 30 seconds to think this through. What type of test can you run? All right, seeing a lot of B's, and that is the correct answer. It's B because for an independent samples t-test, we're looking at two groups on one variable, or one continuous variable, right? Here's our groups, male and female, and here's our continuous variable. How about this one? What test can I run with these two variables? Gender, male and female, and smoker status, non-smoker and smoker. One sample, independent samples, dependent samples, or you can't answer that with the t-test that we talked about. All right, I'm seeing a lot of different answers. The correct answer is D. You actually can't run a t-test with this data. Remember, a one samples t-test, you'll have, we will just give you some mean variable, right? We'll give you the mean of some other previous group, and you're going to compare it to your sample's mean. An independent samples t-test, you need that dichotomous variable, male, female, smoker versus non-smoker. You need only just one of them and a continuous variable, because you're seeing, do these two groups differ on this one continuous variable? A dependent samples t-test, you would need a continuous variable measured twice. So that's none of these, so you can't run a t-test with these variables. All right, let's do one more. Which one of these is an alternative hypothesis for a dependent samples t-test? Take a second, read through these. Remember, we're looking for a dependent samples t-test. So think about, what does a dependent samples t-test do? All right, good. I'm seeing a majority of the right answers, and that is B. We hypothesize that stress scores will differ before and after exam. Remember, what does a dependent samples t-test do? It takes one continuous variable at time 1 and sees, is it different at time 2? We can look at stress before and stress after an exam. I'll just go through and say what the other ones are. So A is an independent samples t-test. B is the dependent samples. C is actually a correlation, so it's not a t-test at all. And D is another example of a independent samples t-test, but it's actually a directional. All the rest of them are non-directional hypotheses. This is a directional hypothesis for an independent. If you got these wrong, I highly suggest, or you don't feel confident in being able to answer questions like these, I highly suggest you go back to this slide and you really try to understand the difference or what types of question each one of these asks. Once you understand this, you can kind of work backwards and figure out any question I would ask. So definitely know this slide, know what each t-test does, and then also go back to these type of slides where the 3 slides where I say, here's the type of data you need. Because once you also understand the types of data, you can then work backwards or work forwards and answer any of the questions I could ask. So know what types of data you need for each test and know what each test answers. All right, for assignment number 10, come on. For assignment number 10, what you're going to do for the remainder of the 25 minutes is you're going to work in your groups to conduct 2 one-sample t-tests on example data. Then you're going to conduct a one-sample t-test using your group's data from your data set. Make sure you clean your data with the age, right? Delete anyone under the age of 18. And then you're also going to need to state the null and alternative hypothesis for each question. So this is what it will look like. Make sure you put, I'm going to open up breakout rooms. Make sure you put all of your, the people who are here, put their names in, give me your group number, and then just work through this. We're going to give you an example, right? We tell you, hey, here's the mean height and the mean weight. Work through this. You're going to actually analyze it. Yeah, you're going to do it for height, you're going to do it for weight, and then you're going to do it for your own study. So if you're using the perceived stress scale in your study, right, do the perceived stress scale one. If you're using the self-esteem scale, use the self-esteem score for your one sample hypothesis, right? So make sure each group will be different. You just got to state the null and alternative hypothesis. Is it significant? Is it not significant? And do the write-up. All right. So I know there's only 20-ish minutes left in class. It should be, for the most part, you should be able to do most of this for the most part. If not, just remember it's due at the end of the day. Only one person needs to submit it per group. So maybe you can divvy this up, divvy the work up amongst you, or you can do it all together. Like I said, it shouldn't take that long. But I'm going to go ahead and open up breakout rooms. Open up what? There's 5 groups? Yeah, the 5 groups. So I went ahead and opened up breakout rooms, go into the breakout room associated with your group number, and start working on assignment number 10. It is going to be due at the end of, at midnight tonight. Only one group needs to, one group member needs to submit it to eCampus. So go ahead, go to your breakout rooms, use the raise hand feature if you have any questions, and I'll jump to your room. Does anyone need me to assign them to a room?
I do.
What,
I do.
Okay, Hannah, what group member are you?
1.
Okay, you can go. Who else?
I
Carson, what's your group number?
5.
Reagan, what's your group number?
4.
4. Toriana, what's your group number?
5.
5. All right, cool.